Okay, all good for the microphone. Hello, hello. All good. Okay. I guess that will be about the time to get started. Okay. Great lunch, everybody. Free lunch, fancy. Hot weather. I hope you are not melting. So I am Neil. I am the head of tech advocacy at Clayton. So you might be having questions. Why are we here today as a standalone layer one? Or maybe even layer two that you consider. But today we're here mostly to talk about the Ethereum equivalence, how from a Clayton perspective, or also from a standalone layer one perspective. So we would go through this topic with the support of Ethereum equivalence and EVM, the equivalence that what we mean on different layer one, layer two blockchain ecosystem. And this is our outline for today. When you look at it, so we give it a bit background on what Clayton is, because this is most of the questions that I have all the time. What is Clayton? And obviously we talk about the rise, about the compatibility, about EVM as a standard, and also talk about the support of the Ethereum equivalence from the Clayton perspective. And last but not least is to cover the implementations, implications, which is everybody maybe care about what is happening with the Clayton in terms of the Ethereum equivalence. So Clayton, in a nutshell, very short term, you put it right here, is like we have our own user experience that we would like to empower every organization with a robust blockchain ecosystem. And what does it mean? Which I will cover in a second. But when you look at, we're just like another blockchain layer one, obviously, but one of the major in the market at the moment. When you look at the ecosystem, these are all the use cases and ecosystem partners that we have. And the whole thing is actually initiated, from Korea, developed by Kakao in the first place. And then you have all this company ground is Christ actually supported. But what are the major offerings right here for Clayton as a layer one, as a standalone layer one? Then you think about the user experience that we're looking to have is the speed and reliability. You look about it's 4,000 transactions per second that we have on the mainnet. And you think about the 1 second, block generation time, which is more like finality, like the immediate finality that we keep talking about right here. You think about we have the layer two, we also have our own layer two service chain, etc., etc. Like these deterministic price structures. And then we're trying to actually benchmark ourselves with other layer ones or layer two in the market. When you look at Clayton right here, when I just mentioned that is the block generation 1 second, and you talk about, it's a bit old, the data right here, but then when you look at it, it's about, top 50. Then you further look at the transaction latency. I just want to go quick on the background about Clayton. But when you look at it, that's actually some kind of, a user test rec that we have, which you can get to the GitHub link about the repository. What you see is the transaction latency. What we kind of define is how much time for a transaction being packaged in a block. But at the same time, obviously, people care about the TPS and all these kind of things about the scalability. But really, it's the performance plus the transaction latency is what a standalone layer one should be looking at. So our latency is around 2.1 seconds at the moment for that specific test cases that you will see. But then, how are these actually being made possible for all these kind of things that we claim that 1 second block time, 4,000 TPS, blah, blah, blah. When you look at it, like Clayton's actually based on a blockchain infrastructure is more like a service-centric. You look at, we have the mainnet right here, which is you got different consensus node, proxy node that is actually for the service chain as well. You got proxy node. So you think about it's a standard 3 node structures that we have, and also we have the service chain right here for different use cases that you might be having. But when you look closer, really, is we have the 3 node structures: endpoint, proxy, core node. Endpoint node, you think about is more like RPC, API for people actually running the APIs right there, and connect with your RPC API modules. But generally, what you will be taking from here will be the consensus algorithm for Clayton's actually with the IBFT and this kind of thing that I just covered already. But what is really different from Ethereum or other layer one is you think about we have a very specific account model. is with the multi-key pairs could be linking with a single account. And the transaction model is, you think about on the on-chain multi-sig, that how we can make it happen is the transaction model is actually with the multi-signatures on the transaction fields in the object. Also with the deterministic transaction calls, because we're basing on the fixed gas price. And this is just a design pattern that we have at the moment. But when you look closer, just go back to 2018, we actually a fork of Ethereum back then. This is not a reason why we are here, but it's part of the reason. But we still, keep contributing for the same foundations that we have with Ethereum. But when you look at on your right-hand side, obviously you got different layers of the architectures. And then when you look at the orange and in purple color, all this kind of thing is what we have been making changes actively since the hard fork that we have from Ethereum. But then why do we do that in the first place? Like, all we care was, if you want to have a dynamics in the blockchain industry, obviously you will be having different layer one, but different layer one, why they're building layer one, not just because of fixing some kind of pain points that Ethereum community is having at the moment, but we would like to have our own UX, our own user experience right here, that I mentioned all the things differently. How are you gonna make the 1 second block time, possible? Oh, is it based on the gas limit that you set? Oh, we don't have the concept of the gas limit. So how do we do that? So we have something we call the computation calls, and multi-sig account control, and all this kind of thing is our own UX, not just to say how you can make it 4,000 TPS or 1 second block time per se. But really, if we have fork, we make changes, then what happens? It happens, your account model is different, your transaction model is different, and then you have different data structures of everything that we put together right here. For example, you might be using the same Ethereum APIs, via ethers.js, but then really this is most important. You may be running with some errors because you have different JSON requests and return format, in your transaction body that will be coming back. And then it turns out the transaction fields will be a bit different. And then we have a problem right here. And then that's why people keep talking about a rise of EVM compatibility, not just from a Clayton perspective, but most of the layer one or standalone layer two, obviously I saw Polygon right here, we're actually thinking about the same directions. And what that is, yes, we are the gift from Ethereum, but then we all believe the EVM is the de facto runtime for us. Obviously people will argue it. We'll have a debate right here. Outside the room, whether WebAssembly will be the one going forward will be the major one. But then we're all here for Ethereum, community conferences, right? I believe we would like to look at how individual layer one or layer two can actually harness the network effect from Ethereum communities, and so that we can have thousands of different use cases actually built on the Ethereum ecosystem. At the same time, we would like to see more thousands of development tools, right, that has been deeply integrated into the EVM. So us as a standalone layer one or layer two, we would love to have some way that we can attract our users, builders, so that on a different levels that we would like to integrate with it and support them. Like how, for example, the core protocol level, can we supporting Ethereum transaction types on, for the first time, so that you can still send your transaction, the Ethereum format transactions into Clayton, it will still be working. So that you don't have to think about to make any specific changes to your use cases or any stuff that you're building on different, ecosystem that we'll be having. But I think we all agree on the point that if we bring Ethereum, or maybe Ethereum, they don't have to a standalone layer one or layer two, to the state that you have an EVM compatibility, I think it will take time. I think better will be for this layer one and layer two standalone to think about how you can do more in terms of the EVM compatibility to make it happen. And going forward is people thinking about EVM compatible is not enough, because what it means is the modifications and the complete reimplementations right there for the low-level code the implementations actually takes time and drive more difficulties and the complexity on working out one solutions only for that case. So that's why people would like to think about compatible is not enough. What we need might be the EVM equivalence. But then what does it mean for the EVM equivalence? So when you look at our roadmap, obviously Clayton 1.0, pre-2021, we thought about we would like to be one of the Ethereum compatible blockchain. But when we know that we need to keep emphasizing our own features and data structures at the same time, than the Ethereum compatibility. But it turns out we did not keep up with any single or any changes that we have from the latest EVM versions. And then things becomes that really complicated that result in we putting many or much effort just to integrate a specific Ethereum dev tools or use cases that have been building on Ethereum to Clayton, if that would be a way right there. And what we believe, after this experiment that we have been doing in the past years, and pre-2021, we believe what we need is really to have 100% compatible, which is these equivalents that we talk about, to keep the original functions. At the same time, we can support the Ethereum functions and most importantly, the Ethereum format transactions. And that's what we would like to say is if you're trying to think about EVM equivalence, is the complete compliance. Just like the Ethereum yellow paper, you put all the opcode right here, you have different guesses, that meaning, all the things that how does it work into what. We want exactly the same happen on Ethereum, but at least you have the mode or environment to support the Ethereum equivalence, and so that you will have more standalone in the layer 1 or layer 2 to think about how to integrate with the existing Ethereum stack. And most importantly, this is something that we would like to see, really the EVM network events we would like to see, and every EIP that will be merged during the time, we would like to see that exact same features or changes that will be happening on our EVM environment on Clayton going forward. That's why we would like to support the EVM equivalence. But before that, we talk about the Clayton case, about the EVM equivalence. What are others, or what have been doing from in the wider industry? Normally, we see if people would like to jump from EVM to WebAssembly, obviously they write all the byte, they compile all the bytecode, they rewrite everything to make sure that will be running on another runtime. But at the same time, you see is a lot of complexity that is being introduced. And the layer 1, for example, for layer 0, like Polkadot or Cosmo, what they do is they have different method. If you look at NEAR, they are going with the EVM, like the EVM environment. But mostly on the layer 0, you think about they are building more subchains like parachain, like the one like the Moonbeam on Polkadot. They're exactly doing the EVM compatible way of it. But when you look at it, most of the solutions that you see, or maybe the operational pattern that you see today, is really going with quite similar to the ETH 2.0. Think about the new consensus or what a new consensus, plus the data availability or this kind of sharding pattern that you have to be more scalable going forward. And then finally, we are here about the EVM equivalence, about the Clayton case right here. So EVM equivalence has always been the major pillar that we have for the Clayton 2.0 initiative. So if you want to learn more about Clayton 2.0, you can check out our light paper right here as a reference. But what does it mean? It means we finally would like to do more than EVM equivalence. We would like to support of Ethereum equivalence, meaning that every single EVM features that will be available on the Clayton core protocol. And Ethereum development tools, for example, you think about ethers.js and all this kind of the ethers API libraries, they will be happening and being totally applicable for the use within the Clayton ecosystem. And that's why you start seeing something ETH namespace API that we support, that will support the full Ethereum transaction format into the Clayton ecosystem. But then if you can support Clayton format and Ethereum format and Clayton format transactions, then you need to think about how you support it at the same time, but you can also distinguish it from each other when this transaction going to the transaction pool and further being packaged to a block. And we're not just talking, seriously, the whole thing is being released on the version 1.8 that we have for Clayton. It's actually back in a few months back, just before April, we actually released it, and things has been working well, working all fine. But we go deeper. What do you mean by Ethereum namespace? But you look at the test stack that we have for Clayton right here. Is people build their dApp solutions, and they can also have their developer environments per ecosystem. Obviously, Ethereum got tons of those, and we would like to see more on Clayton that can work out an integratable versions, or just think about how it could be interoperable between different chains. But really, this is the main part is on our JSON RPC, on our endpoint node that I mentioned previously, you can start seeing more Ethereum API, and this Ethereum API with an Ethereum namespace that they can support all the Ethereum all the Ethereum formatted transactions that will be going, obviously being processed by our EVM Plus, which what we have been branding as a KLVM, Clayton VM. But then there's so many implications right here is about the pre-compiled contract. What does it mean? Like there's so many things that it's not just you plug in the Ethereum namespace, then the whole problem will be solved and you don't have any problem. You can process Ethereum format transaction. It's not like this. It's actually, we do have a lot of implementations, implications if we're trying to do this. Obviously, we are not trying to kill ourselves, but we would need to harness the network effect into the Ethereum ecosystem at the same time to bring more users, to extend their use cases. Maybe they have the developer tools, maybe they have different use cases built on Ethereum already. We would like to see that happening, that building on Clayton. So when you look back about when we talk about the Ethereum equivalence as a major requirement that we would like to have, and obviously, there are some more requirements that I mentioned already. You need to, have every EVM features that will be, support right there on your VM level or Clayton VM, and then you need to. Actually, I don't have to walk. I can just do this pointer. So, so you can support all the Ethereum development tools that you think about that will be usable on Clayton. What I mentioned, you support the API format with the ETH namespace. That will be available on endpoint node, so you can access these kind of Ethereum APIs that as you go. But then when you look at these four major, which I have only mentioned that already, you will look at actually some implications. Like for example, when you look at this, okay, so it's easy that you say you can support EVM features. Then what about the transaction types that like the EVM start having, like these, like the dynamic fee that's starting from EIP 1550 Lite? How are you going to do that because you don't have the gas limit concept, you don't have the dynamic gas fee concept. How are you going to do that? And also the transaction fee, not every transaction fee is actually having on both blockchain ecosystems. So how are you going to deal with it if you're going to, having the EVM equivalent support right here? And it's really a lot, like these pre-compiled contract, the references will be different. So you think about, for these as well, some transaction fee may not even be used, even though after that, after the integration with the EVM, equivalence that we're having, because we're not using proof of work. Like, why do we even have feels like difficulty and all this kind of stuff, like the gas limit? So when you combine together, obviously we have few more, but then some generalized, pain points. I don't think it's a pain points, but then you think about it's more like the implications that we see is, okay, so you can, okay, Neil, you told me that you can support Ethereum equivalence or EVM equivalence per se. Then what about the pre-compile? Because now, Ethereum, they got pre-compile contract as well as specific address. Then obviously you will be having some kind of caching using the same address. So obviously, for these situations, we do the update so as not to have the overlap, because when you look at this case, exactly the VM log, when you look at OX09 that we were using, but that will be cached with the Blake 2F, which is more like the generations of the hash functions that we have support in the Ethereum ecosystem. And then also for the fee payer validate senders that we have, and obviously for these, we make the changes for the addresses as well. We don't want to have these references will be clashing with what we have. And also, it really depends on the deep down people using on their maybe proxy contract or maybe any contract that they have their own pre-compiled contract. They may be using call method, delegates call method right here. It could mean differently because when you know if a call is happening from an EOA account, meaning that you don't have the access to the chain data when you actually make the call from it, also mean that it will have different behavior, because if you look at this, if you're using delegate call, they always kind of refer to the latest pre-compiled maps right here all the time. So what you actually had before will actually be different from after the hard fork that we have to support the EVM equivalence. And so to speak, for the transaction types, there are a lot of transaction types that, not really a lot, but only 2 that we see that is major stuff that we like to support. But then really when you look at it, that there are different implications that you can see from different transaction types that we need to start supporting after these kind of hard fork to support of the Ethereum equivalence. And also, yes, you can support both format of the transactions, but you have no control because it's a decentralized network. If your transaction sender would like to send a Clayton format transactions and being processed to a smart contract that is running with these Ethereum APIs, then obviously it's at your discretion as a user, but obviously we can do much better on the error handling to tell you exactly the model that you send is actually mismatch of the one that being processed on your smart contract. So on these kind of things that obviously we will have these kind of implications combined together. But if you want to go deep, always refer to maybe this recording of the presentations and also get to the, maybe you can get the slides somehow and you can just have a look and keep asking questions to our community out here. Really to conclude, I think we've still got some time to conclude. 5 more minutes. We believe EVM equivalence is an industry standard. So we don't think in a way that we are a standalone layer 1 or layer 2, then we must be competitors of Ethereum. Not like this. If we believe EVM equivalence is an industry standard, and you think about there are so many EVM compatible chain, you're essentially building a bigger cake. And we treat Ethereum as a layer 0, and we build on the layer 1, and we base on the EVM, we make it EVM equivalence. And obviously, it creates an enormous opportunity to experiment innovations without touching the Ethereum mainnet. So we don't make any influence to the Ethereum mainnet. You can always have the innovations on the layer 1 or even on our testnet to make something happen, because we believe Ethereum is now too big. When you look at the merge, it takes time. It's now too big to be flexible to changes, not to mention changes to support your layer 1. So things must be coming from layer 1 or layer 2, standalone, to contribute to the Ethereum ecosystem to drive this forward. And when you think about KLVM is EVM equivalent, and we actually enable the support of Ethereum equivalence by saying that we can support the 100% the same of Ethereum formatted transactions. In these 3 areas, the development tools, EVM API, and core development contributions that we could have, so that when you actually contribute to EIP, you contribute to KIP as well. So one or the other, you're still contributing to the Ethereum ecosystem. Finally, going forward, this is just my thought, is if you believe EVM is a standard going forward, and obviously there have been so many EVM compatible chains, so I mean not this one, this is equivalent, these guys, then you think about it's actually an ecosystem, an EVM ecosystem that people are trying to build, and then you start looking at a lot of opportunities between EVM cross-chain, the bridge that we talk about. And also, it might be time to go back to a discussions about EVM to EVM, or what Vitalik has been saying, the EVM in EVM opportunities that we might be having, given that we have more EVM compatible chains, or maybe chains or layer 1 or layer 2 that with the EVM compatible support right here, then we can have more opportunities going forward. So this is the invitations for everybody right here. If you're developers, feel free to scan the code if you want to join. We would love to have you to build on our ecosystem, be builders to contribute. We have a lot to contribute to, or to our own ecosystem and also to the Clayton ecosystem. And we have a lot happening. Obviously, you know, hackathon is the best way. We give the prize, you have your incentives, you come to join, you get your prize, contribute to our ecosystem to build more tools towards the bright future of EVM equivalence at Clayton and also for the EVM ecosystem growth. That would be me, a bit long, but if you would like to get more information about Clayton, just to scan the code right here, you will get the link tree, you will have all these kind of channels that go through. Do we have any questions on the floor? If that will be many, we can take it outside the door. I would just stand there and just to mingle and answer all the questions that we have right here. I don't, do I have to? Yeah, okay, yeah. Any questions? Don't ask me what is Clayton, because I don't want to do that again. Yeah, go on, yeah. Oh, sorry.
Yeah, Sak Neil for the very good presentation. I'm from Verilog Solution. I'm a co-founder there, and I'm also a professor from UBC. Actually, then we submit a proposal to Clayton, and it's kind of the yeah. So my question basically is that do you have any plan and for example, because Solidity code has the deficiency, and a lot of those the EVM equivalent chains, they would like to build their own languages. So I want to know, does Clayton has this plan? The other question is about the zero-knowledge proof. We also have some chains and try to develop some privacy protection mechanism in the chain. So also would like to know more about this kind of thing in Clayton.
So I guess I'll just answer. So for the first one, if we're trying to build under languages, that you need to think about the equivalence of it afterward. So what's the best strategies to do right now is to keep using what we have, like with the Solidity. We keep building. We're not going to create new languages, call it something kind of fancy name, Clay, blah, blah. But the short answer for you will be we keep using Solidity for what we have been using. Maybe, you know, maybe we support more languages. We don't create, but we support more languages that go into the Clayton ecosystem. You know, Cairo and Viper, obviously all this kind of thing. We want to keep supporting Viper, maybe a bit going down, but then you look at Cairo or Solidity will be the main languages that we cover. And also I think for zero knowledge proof that you mentioned, it depends on the applications, right? I think very quickly, but you think about, we do have plans, think about these layer 2 plan that will be running on Clayton or Ethereum ecosystem that is running with these you know, CK rollup that we might be having this model, but this application will be what we've been thinking about the zero knowledge proof, but I guess that will be everything that I have.
Thank you.
Cheers.